Welcome back to Concepts in Arithmetic. We are continuing our study of the algorithms for the four operations of arithmetic. In a previous video, we had introduced the long division algorithm. And you'll notice in that video we had focused on single-digit divisors only. And there's a reason for that. That would be one, it would be the first stage in developing the long division algorithm. And number two, there is an extra component needed when you are working with multi-digit divisors. Okay, so remember, if we're thinking about how do we teach this to students in the K3 curriculum, we have to kind of dissect the methods that we have been using on autopilot for a long time. So let's start with a little warm-up example. We're going to compute 492 divided by 6. So if we do the long division algorithm, okay, what we would think, the way we're thinking is, okay, 6 going into 4, no, it doesn't work. 6 going into 49, we know that goes 8 times. For a 48 here, we do the subtraction, a 1, and then we drop down the 2. 6 goes into 12 twice. Okay, now, thinking about this step right here, okay, this step is kind of easy because we know the times table for 6. Okay, that is typically not going to be the case when we have more digits in our divisor. Okay, so let's look at a actual example where estimation comes in handy. Okay, so in this example, what I want to do is I want to do 16. Okay, so that's a 2-digit divisor, and I'm dividing it into 9, 1, 5, 2. Okay, so 16 is my divisor and 9,152 is my dividend. Okay, so in grade school I never learned my times table for 16. Okay, so it's kind of handy if I estimate with kind of a nice number for doing multiplication. Okay, so I'm 16 into 9, that doesn't work. 16 into 91, well, let me think here. Okay, I could just kind of count them off, right? 16, 32, 48. Oh gosh, what's the next one after 48? So 16, 32, 48, 64. Can I fit one more in there? 64 plus 10 would be 74, so 80, and I think that's the max. So 16 times, what is it, 5 gives me 80. Okay, so I'm having to do some kind of mental gymnastics there to deal with the 16. Okay, I'm having to think that out the whole time. In other words, basically what I'm creating in my head is almost this little times table for 16 here, right? 16 times 1, 16 times 2, times 3, times 4, times 5, times 6, times 7, times 8, and times 9. I don't need 16 times 10 because I would never have to put more than one digit here in any spot, so I don't need to worry about that. Okay, this one's easy, 16, 32. We actually know this when we just did it, it's 80. Okay. We know that very handy trick for doing mental math, multiplying by 9. 16 times 9 would be 160 minus 16. 160 take away 10 would be 150, take away 6 more, 144. 48, 64, 96, 112, 128. Okay, so this times table for 16 is going to be super handy, right? Because 16 times 5, we figured out that's 80. We subtract 1, 5. Okay, so now I'm thinking about what's the closest multiple to 115 without going over. It's right here. 16 times 7 is 112. So we subtract, we're left with 3, 2, and now that's an easy one, that's 2. So our division has come out even. All right, now, you don't want to create this table every single time you got to do a long division by a 2-digit number. Okay, it will be a nightmare. So what you can do is you can use estimation to help you find the multiples that work without having to write this out. Okay, so this is not a great way to do it. Not going to do this every time. What we're going to do is we're going to use estimation to help us figure out the multiples that work. Let's look at another example, and we'll do estimation to help us find our answer. Okay, so in this next example, what I want to do is I want to compute uh, 29 divided into 1, 6, 5, 0, 0, 1, 8, 8. Okay. Pretty big, but it's a long division problem, right? It's grade school math. Okay, now, multiples of 29. Ugh. Multiples of 30. Very easy to find. Okay, so when I'm looking at this first step, 165 divided by 29, very hard. Let me think about multiples of 30, and now it's easy to see what I should use up here. I should use a 5, right? Because, and over here I'll put some notes about my thinking. So I'm thinking about 165 divided by 29. Well, that would be approximately equal to 165 divided by, divided by 30. Okay, still a little too tough. I'm going to trade it in again. A better thing for me to look at would be like 150 divided by 30. And really, I was thinking, okay, what are multiples of 30? Of the multiples of 30, which one gets me closest? And it's pretty easy to see that 5 times 30 would get me to 150. And that's probably as close as I can get with 29, too. Let's find out. Okay, so we multiply here. Well, if I did 5 times 30, I'd have 150. So this would be 145, because I want 1 less 5. Okay, so 2, 0, 0. Okay, so now I'm going to 200. All right, but I'll still think about 30, okay? How close can I get to 200 with multiples of 30? Well, I think 180 is probably it, and that would be 6. So 6 times 30 gives me 180. I don't really want 6 times 30, though. I want 6 times 29. Okay, so this would be 174. Okay, we do this subtraction. I get 26,260. Once again, keep focusing on that 30, because multiples of 30 are much easier to find. We're going to use those to figure out what we put up here. Okay, so using multiples of 30, how close can I get to 260? Well, I can get to 240 by doing 6, or no. If I get to 240 by doing 8 times 30, right? 6 times 30 would get me to 180. So 8 times 30, that's what I need. Okay, Now I have to do 8 times 29. Okay, I know 8 times 30 is 240. So 8 times 29 would be 232. Okay, did you see how I got the 232 from the 240? If I had 30 eights, if I had 30 copies of 8 added up, 30 of them would get me to 240. I don't want 30 of them, I only want 29. So I need 8 less than 240, 232. Okay, 2, 8. Right, do the subtraction algorithm. The 1 comes down, 281. Now we're thinking about 30 going to 281. I think I need a 9 here. Okay, 9 times 30 would be 270. And of course, to know that, we just need to know 9 times 3 is 27. Okay, so 9 times 30 gives me 270. 9 times 29 would give me 261. 208. All right. Can I get away with the same thing I did before? Let me see. Suppose I did that. Suppose I tried 6, because that was kind of close. Okay, suppose I try 6. 6 times 30 is 180. 6 times 29 is 174. Okay, now I notice right here, I can actually get another 29 in. Okay, so I'm going to kind of adjust my algorithm there. It's kind of self-correcting when I see, hey, I could have gotten closer. I could have gotten closer by doing a 7. Okay, so 7 times 30, that would be 210. Back it off by 7, 203. Okay, now we got 58. Oh, okay, that's an easy one. 29 times 2 is 58. Okay, and then we're finished, right? We've got to the end. Okay, so notice this whole time, I wasn't thinking about dividing these various numbers by 29, because that's a pain in the butt. I was thinking about dividing by 30. So I'm using estimation to guide my choices up here. Okay, now one of the times my choices ended up being wrong. Well, so I just fixed it. Okay? So here's what estimation is about. Okay? Estimation is about finding an approximate answer to a given computation. Okay, so we're trying to find an approximate answer to get us started. And when we're doing our estimation, we want to use place value properties to find a similar, easier problem. Okay, we want to find a similar, easier problem. So, plenty of places estimation could be used. Let's say this. I want to say how many days are there in 100 hours? How many days are there in 100 hours? So The actual answer I'm looking for is 100 divided by 24. Okay, now we might be able to do that, but this would be a much easier problem. Divide by 25. So if you only need an estimate, if you only need an approximate answer to this question about how many days are there in 100 hours, well, it's approximately 4 days. Okay, it's a little more, but we can get the approximate answer very quickly. Here, I think I might actually have to do the division. Okay? So, estimation is good. When you need rough answers. Estimation is also good for checking complex calculations. Okay, so this isn't something you would give somebody in K3, but you may very well have to do a calculation like this in a high school or college course. Okay, so obviously this is something we would do on a calculator, but it's always a good idea to see, is the answer the calculator is giving me in the ballpark? Am I about right? Well, here's how we could check something like this. Replace these numbers with nice round numbers. Okay, so it's about 120. This is about 2. Down here, that's about 3. 120 times 2 is 240. Divide by 3 is 80. Okay, so your answer should be about 80. Even if you had to compute the exact answer with your calculator, you can do a quick check here and see, is that about 80? If it is, I probably got the right answer from my calculator. Okay, so good estimation is going to involve rounding your inputs to numbers that are nice to do the computations with. It's not going to be any advantage if you replace this by 123 times 1.9 times 3.3. Yeah, you rounded, but it's still a complex calculation. Okay, so you want to round to stuff that makes the computation something you can do mentally, because that's what we're going to be having to do in the division algorithm. Okay, so the beginnings of estimation are going to help us with that division algorithm.